So as I mentioned, I wanted to kind of review some things that we've already talked about, but really focus it into thermodynamics. So just remember energy. We've talked about energy, kinetic energy, but heat is how much energy is going to be transferred. So our units that we want to focus on, joules is our primary unit. But remember, we talked about a little bit that you can have calories when we're talking about food, but we can also have little c, calories. So one capital calorie is equal to 1,000 little calories. So you know that 200 calorie candy bar that you eat? It's really 200 capital calories, which is 200,000 calories. So how much of this is in joules? So let's kind of convert this. We know that one calorie, lowercase c, is equal to 4.19 joules. So if we do some unit conversions, and let's practice, it's been a while since we've done unit conversions. So if I bring this in here and I do 1 calorie, it's 4.19 joules. That means if you eat a $200, wow, sorry, 200 calorie candy bar, you're eating 838,000 joules worth of energy. So just kind of that capital C, think about it. Do you want to know that you're eating 2,000 or 200,000 calories and also lack of space? That's why the food industry uses the capital C as a space unit, just to save space. We do it in astronomy all the time. We come up with a new unit, so we're not writing the big numbers, and so it doesn't get so daunting. We've talked about the laws of thermodynamics. So remember the first law, energy cannot be created or destroyed. Energy is always conserved, but can be transferred from one or the other. So we've talked about that. So we can add energy into the system. So work has got to be done. So if you're talking about engines and stuff like that, you add energy to the system. You add electricity to your fridge for it to run. So a lot of times, second law of thermodynamics really shows that things can't run on their own. So we have to add energy to the system, but we're getting that energy from somewhere, okay? So energy cannot be created or destroyed. It's going to be transferred from one form or another. You're not going to all of a sudden create thermal energy. Entropy, we talked about as well. So the second law, the law of entropy, where things will become more disordered. So how I want to word that with energy is, oops, sorry about that. So when we're looking at the law of entropy, and the energy module, we kind of went through and talked about it in general terms. But when it comes to heat, we know that energy flows from hot to cold, but you can force it to go backwards. But it has to be forced to go from cold to hot. It's not going to happen on its own. It's not going to spontaneously happen. So in nature, energy flows from hot to cold. Again, you can force it to go backwards. It's like two protons. You can force them to slam together, but they're not going to happen together on their own naturally. So again, this is entropy. So the systems become more unorganized, and we're going from high energy to low energy. And a lot of times we're producing energy that can't be reused. So we're producing non-usable or low quality energy. Now there is a third law, and basically we've already talked about that, is that we cannot reach absolute zero. Even though we're trying, we can't reach it. So I want to kind of go through, I know more verbalizing, this is just kind of a review, make sure we're on the same page, looking at the laws of thermodynamics and really focusing them on energy, thermal energy, as opposed just in generic terms of energy. So kind of make sure we're on the same page and using the same units. Again, being familiar to going from joules to calories with a capital C. So you can kind of go through, kind of keep these unit conversions in mind, especially if you're going in the medical field or nutrition or something like that. A lot of times in chemistry and stuff like that, we'll focus on joules, but in the medical field and specifically in nutrition, they focus on calories. So if you're going into like nutrition, dietitians, the physical fitness people, you'll be using calories instead. It would kind of freak somebody out if they walked up and said, I ate 1,000 joules. People would kind of be confused about what they ate. So I'm just going to keep that in mind, being able to use all the units and being able to review these laws of thermodynamics. So next we're going to go through and start looking at applications. How can we apply what we're using, and then keep moving on through the study of thermodynamics.